Wait.
Hello, and welcome to Isaiah's Masterclass. Today, we will be learning about statistics. We will start in Chapter 4.
Chapter 4.
Regarding probability. Yay. What does that say, Chris?
Types of probabilities.
First one,
Number 1.
a priori. Number 2, empirical.
Isaiah, is a priori Italian for prior?
You know, it might be. It might be. Now, on the right here, I am going to write 3 things in no particular order.
Okay. That says differs by opinion.
Differs by opinion, based on data and based on prior knowledge. Now, Chris is going to take this marker
Cool.
and connect which ones go with which.
All right, let's take a quick look. It's getting rainy outside. I got distracted. Based on prior knowledge. This is definitely, subjective, all right? Based on data, empirical. I think it just reminds me of empiricism. Okay.
We're gonna have to try that again.
Differs by opinion. Based on like that.
Exactly.
Got it.
Nailed it.
Nailed it.
Everyone take a nice look at that. So Chris, what is a priori?
A priori is based on prior knowledge. You got this, the core words of okay? Then we move along to subjective. Differs by opinion. You can easily remember this by, there's a C in subjective and not in that, okay? Empirical, based on data. Both of these, there's no B in empirical, okay?
Now, let's talk about some events. It'd be kind of cool if you were like, events.
Events.
Yeah. So, we have a couple kinds. Simple.
Events. That kind of looks like skimple, but it's simple. Joint events.
Now, simple events
Yes.
are events with one characteristic.
That sounds simple.
So simple. Joint events involve
2 or more.
2 or more.
Oh! Wow, that sounds joint, like a marriage.
Exactly. Where 1 or more, 2, typically 2 people are joined in holy
Become
matrimony.
one flesh.
Next, you want to know, so if we're talking about event A, right?
Yes.
And we want event A to happen. But there's this thing called a complement. So what if A doesn't happen? So like opposite of A. So this is our simple event. And then we have our complement, which is A apostrophe. Zoom in on the apostrophe.
A apostrophe.
That is how it is denoted.
Denoted.
Okay, you can. Next, let's talk about contingency tables.
Those are my favorite type of tables.
Please enjoy this time lapse of me drawing a contingency table. Now, from our contingency table, we can display our data in the form of a
Decision tree.
Yes. Woo. Apple tree.
That's beautiful.
Thank you.
Looks like a cookie with some legs.
It's gonna go away. Okay. Now let's talk about our decision tree. I didn't need it anymore. Now you're gonna make two nice branches. I like to draw little shapes on there because it looks nice.
That's look really nice.
You're gonna draw two more branches off of each of your shapes. Now, let's go back to our contingency table.
We shall.
With the color red, I'm going to denote each of these using one letter variable. So study will be denoted S, while not study will be denoted by its complement.
S apostrophe.
Exactly. For pass, we will put P and fail.
A P apostrophe.
Very nice. Now if we head on back to our decision tree, it might ask something like this. What is the probability of someone passing or someone not passing? Any idea, Chris? If we take a look at the contingency table, what is the probability that someone might pass?
0.5.
There you go. Merwin would be proud.
Yeah, he would.
What is the likelihood that someone might fail?
Oh, you know what? I think we should just do the same thing and put 0.5 again.
I agree.
Thank you.
Now, as we go, it'll ask us more, such as, what is the probability that someone studied and, well, given that they passed? And vice
Okay.
versa,
What?
what is the probability that someone didn't study and passed? Chris is confused.
Yeah, okay, well, you changed your
let's
sentence.
start over.
Yeah, let's.
I
Just
want
hold
you-
on, I don't want Beth to be confused. I definitely got confused right there.
Ready? Ready, Beth? Ready? Okay. What is the probability that someone studied given that they've passed?
That would be 80.
Over?
Over that one, 110. Which,
Sorry, no.
Let's just
it
do
would
some
be
math.
it would be this over this.
right. Well, let's explain that.
Because this.
Oh, because they passed. So you're going to just.
So
follow
given that they've
along.
passed, how many of them studied? 80 over 100.
Yes.
So then
Got it.
on the other side of this
Out of how many
branch,
passed?
we're gonna have probability
The opposite.
of not studied but passed. And that of course is going to be
0.25.
just 2.
Just 0.2. Never mind. Shh. 0.2.
0.2, Beth. 0.2. Now, on this branch, we're going to have probability that people studied given that they did not pass, and the probability that people did not study given that they did not pass. So, Chris,
Yeah.
out of the 100 people that did not pass, what percentage of them studied?
That would be 0.3.
Yay! And how many of them did not study?
0.7.
Exactly. So there is our beautiful decision tree based
Wow.
on our contingency table.
Beautiful decision tree based on contingency.
Yeah. Hello again. Now we're talking about a couple different types of probability. We already mentioned simple and joint events, but let's talk about simple and joint probability. Sound good?
That sounds amazing.
Woo!
Really excited about that.
So, simple. That is when how many characteristics are at play?
1
Exactly. That would be, example of that would be, what's the probability?
of an egg.
Nope. So, pick one day
Alright.
out of 2018, okay? So
Got it.
what's the probability that that one day will be a Wednesday? That's an example of simple probability. 1.
You know, that makes sense, Isaiah.
Yeah. So joint probability is when we'd maybe have 2 factors. Like
Yeah.
what's the probability that the day you pick is in January
Oh!
and it's a Wednesday?
Wow. You know, that's 2. That's 2 probability.
Day of the week and month. Crazy. So, you should know that this is very important, this word right here. Can you
And.
read that word, Chris?
And.
And. So you want to know the likelihood of both of them occurring.
Both. They both have to occur.
Now, let's talk about conditional probability. But the conditional probability refers to the probability that a given event will take place given that another one has already taken place. If we think back to our decision tree,
Yeah.
we were trying to figure out the probability of something given something had already happened.
Yes.
So, the way these conditional probabilities are going to look is, what is the probability that, so let's talk about cars, you know? What cars, and we want GPS and we want AC.
Yeah.
So what is the probability that a car has GPS given that it has air conditioning?
Given.
So that means, what all that does is it shortens our sample size. So if there's 100 total cars, 50 of them have AC, 30 have GPS, and 20 have neither.
Let's get that 20 out of there.
But within here, 20 have both. Does that make sense?
Yeah.
So, what is the likelihood that something has GPS given that it already has AC? So we're only going to then look at our 50. So then how many have GPS out of those 50? It's going to be that 20. 20 out of 50. Is there any confusion with that, Chris?
You know, by the end of it, I was good.
Now, there's another way to do this. They give us a formula, and it looks like this. Probability of A given B is equal to the probability of A and B and B divided by the probability of just B. So mutually exclusive events are events that cannot occur simultaneously. Make sense?
Yeah.
So, an example of this, randomly choosing a day out of 2018. What's the likelihood that it's in January? What's the likelihood it's in February? Do you understand how these cannot occur at the same time?
Definitely. Those are 2 different months.
Explain to us how a day in January cannot be also a day in February.
Everybody, take a quick look at, here your calendar is. It says January on it, okay? This one says February on it. They're 2 different calendars, okay? They might have 4 weeks in each of them, but these can't overlap. That's a no, and that's a no-no, okay? Thanks, you're welcome.
Now, let's talk about collectively exhaustive events.
I love collectively exhaustive events.
Now, collectively exhaustive events are when the set of events covers the entire sample space. Okay?
Yes.
Example. What is the probability that a day chosen out of the year is in summer? What's the probability it's in winter? What's the probability it's in fall? And what's the probably it lands in spring?
Nice.
Spring. Do you understand how all these events cover the whole 365 days?
Yeah.
It covers the whole sample
That's
space.
the whole sample space right there.
All of it. Got it? Welcome to formula time.
Formula time.
Now, to compute simple probability, it's easy. Probability of A equals the number of A outcomes over total outcomes. Simple. Got it?
That is real simple.
So what's the likelihood that if you're picking a day of the week, it's a Wednesday? Well, how many Wednesdays are in a week, Chris?
Wednesday.
Okay, so how many Wednesdays in a week?
1.
How many total days in a week?
5. 7.
7. So this tells us that our probability of picking a Wednesday
Yeah.
is 1 out of 7. Simple. Joint probability. Okay? This wants to know what's the probability of A and B. Does that make sense?
Yeah.
Cool. This equals the number of events of A and B. A and B, got it?
A
All
and.
over total outcomes. Let's come up with another example. Let's say you're picking 2 days out of a week.
Yeah. Monday,
no,
Thursday.
wrong.
Oh, sorry.
I'm wrong, but I forgive you.
Thank you.
Let's go back to our idea that we're picking a day out of the year. What's the likelihood that it's in January and it's a Wednesday? Okay?
Yeah.
We can do this, Chris. So, let's think about this. How many days are in January?
I don't know, probably 31.
Total outcomes?
365.
365.
Got it.
Then we have to look. What number of events satisfy both A and B?
Wow.
So, how many days in a year are in January and are a Wednesday?
Wow. You know? We got January's, but we're doing days. I don't know, is there 31 days in January?
It doesn't matter.
Doesn't matter.
If we know
Let's do 31, because that's just a cool
if we know that there's 52 weeks in a year
Yes.
and there's 12 months, what's 52 divided by 12?
You know what?
So write 4 above 365.
4.
That is the number of events that satisfy both January and Wednesday. Take this back before you hurt probability. I think we already mentioned this one.
You know, this flow really helps, Zay. Simple joint conditional.
Yeah, it's really nice. So, what is the probability that A occurs given that B has already occurred?
Given.
So, this is the probability of
Thing I said.
probability of A and B all over the probability of B. Just like that.
All right.
That's how you do it. It's called independence.
Day. If you didn't know, it's a movie. It's also a day.
It's
Our
also
country.
something we have in the United States.
It's beautiful.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So it didn't actually say independence, but
Independence. So independence in terms of statistics.
God loves us, you know? Sorry.
Can we get back to statistics?
Okay.
Independence in form of statistics is this. When P of A given B is equal to P of A. So what that means is that the probability
It doesn't even matter.
is not affected by the probability of B.
No
Has nothing to do with it.
2 more things.
Let's go. First one, perms.
You know, that's what you get at the hair salon.
Psych. Mutations.
Oh, you got him.
Gotcha.
Got her.
Permutations.
Wow.
So a permutation is a way of arranging. My laptop's arranging X objects from N objects, comma, order matters. Okay? I'm going to give you an example. This is what you need to remember. What do you need to remember, Chris?
The order matters,
Boom.
alright?
Let's do a quick example.
Permutations.
I'm going to give
You need a combination for a lock, right? You have your good old padlock on your bike,
love that.
right? And you need 3 numbers. All the numbers, let's say, are between 0 and 9, okay? So we have 10 total numbers. Now, you want to arrange these 10 total numbers in a 3 combination lock. Does that make sense?
That makes perfect sense.
So, what you're going to do is, let's think about it. Order matters, right?
It does
Order
matter. It
does
definitely
matter.
matters for padlock.
So, all you need to know how to do is forget about this. Is know how to go to Excel and type in equals perm, and it'll pop up with this little sidebar, and it'll say permutation. And you're going to go ahead and click it. You like my cursor? I drew a
Yeah.
cursor. You're going to click permutation, and then it'll prompt you to add numbers, like picking 3 out of 10. I think that's what it looks like in real life. But Excel's going to do it for you. That's all you need to know. All you need to know is permutations, order matters. Now, Perm.
Let's talk about a combination.
I'll get a cool nose shot.
Now, combination
Combination.
is the same thing, but guess what?
The order doesn't matter. Oh man, let's just switch it up right now. I'm doing a lowercase n.
This one would look like this. 10, choose 3. You know, that's what it's gonna look like. But
See.
again, go to Excel.
Type in comb.
This little sidebar is gonna come up. It's gonna say com. You're gonna click on it. Boop.
An easy way to remember is when you get a perm, you're getting a perm. So in Excel, you put in perm. If you're getting combination, you're not getting a perm, so you use a comb. Nice.
Hey Beth,
Good morning.
it's Isaiah,
I'm Chris.
and we're here again. We're gonna be
welcome.
learning about Chapter 5. Whoa! Chapter 5, Business Stats.
Chapter 5.
Chapter 5 is about discrete, probability, distribution. Yes. First thing we're going to do is make another contingency table. Because it's going to help you understand everything.
I freaking
Think about it this way.
probability distribution.
Let's think about this.
Okay.
Let's say you're working,
Mm.
and every day you get interrupted, and you want to know how many times you get interrupted.
How many times does Janet interrupt me? Janet from the coffee aisle.
So we're going to put interruptions per day, and then on this side we're going to put probability, aka frequency. Okay? We're actually going to put frequency first, and then we'll put probability. Prob. Got it?
Got
So,
it. Makes sense. It's just the way it's laid out, man.
Yeah, it's really cool.
Beautiful.
So we have 0, 1,
2.
2,
Here we go.
3, and 4.
4.
So,
What's the frequency of Janet interrupting us?
0 times.
0 times.
2? Sure, let's just
Sure.
make it up. 1, 3, 2.
15.
That's
It's a
larger
little
than I
steep,
anticipated.
but-
Let's do 1.
Three.
And then
Let's do 3.
4, and then 0.
Yeah, that's
Okay, so we have a total of 10 10 whatevers. So the frequency for this is 0.2, 0.3, 0.1, 0.4, and 0.0. Does that make
wow.
sense?
I think so, man.
Cool. That's what we're looking at now.
Just always dividing them by 100. Is that? We just get those nice
It's
even probabilities.
it's this over this,
Gotcha.
right? Total.
Okay, that makes sense because of 10.
Right. So
Sorry,
Let's
we're
talk
doing
about this
0
now.
to 100.
there's this thing you need to know, Beth. Okay, listen, Beth. I need you to listen right now. Okay, really focus.
On your listening ears.
I need you to understand this. Expected value, aka Chris, at that word. Mean.
Oh,
Not like when someone's a jerk to you. Mean. Like
like add everything up and divide by how many numbers there are.
average. So we just have a couple words here. Expected value. Want to know how to find the expected value?
Yeah.
Okay.
I love that.
This is how it is. X1 times P. What that means is it's your number times its probability. So let's head on back to our table, Chris. If we wanted to find the expected value mean of 0, you take your probability, multiply it by 0. So if we added a thing here that said mean, it'd be 0, be 0.3, be 0.2, it'd be 1.2,
Yep.
be 0. But that's not our mean. Our mean is the total of that. So 0.5, 1.7. That's our mean. Do you understand how to find our mean?
That was beautiful. Hello.
The variance,
Variance.
Anything you want to say about the variance, Chris?
You know, it's variance.
Very cool, as I was going to say. You know, very. Variance is this. It's x minus the mean squared. Okay?
Sounds good.
Standard deviation. Standard.
Beautiful. Deviation.
Is x, your number, times the variance. I don't actually know if that stuff is true. That's what's in my notes. I hope it's real. The real equations are really long. That's a beautiful sky.
It really is. Look at all the clouds.
Wow.
Thank you, Jesus.
Is binomial nomenclature, that's like scientific names. Photo of us
I can draw one for you.
getting second place.
Aww.
That- History shows that 80% of students like Krispy Kreme.
Sorry.
That 80%.
Like Krispy Kreme.
I think that is an accurate statistic. But let's talk about this. So, what you might be asked is a sample of 5 are tested. You know, they're asked, do you like Krispy Kreme? Right? That's what they're asked. Then they're going to ask you like, okay, what's the probability that 1 likes Krispy Kreme? Now, are you ready for something awesome? Come over here and look at my laptop.
Wish.
You're gonna, come on. You're gonna, during the test, if there's a question like this, you're gonna go and you're gonna find, this one, this binomial Excel sheet. So, boom, there it is. Look at that. Make it really big. Now, in sample size, do you remember what our sample size is, Chris?
You know what? It's 5.
Yes. Do you remember what the probability is that someone will like it?
80%.
Exactly. Now, once we have that, we can look here to see what the likelihood is that one person, only 1 out of 5, like Krispy Kreme. Do you see it, Chris?
Yes.
Boom. 1. It's like
No, I can't see.
0.006.
006.
That's how you use that, okay? That's how you use this binomial sheet. And that's
really easy.
But there's another thing. Come over here, Chris.
Okay. Here we go.
They might ask, what's the probability that 3 or more like Krispy Kreme? Now this is where we should be. In a sample of 5, at least 3 people should like Krispy Kreme.
Yeah.
So it might ask you this, 3 or more. Let's go back to the binomial thing here. So 3 or more, there's 2 ways you can do this. You can get 3 and 4 and 5 and like put them together and look down here at the sum. Uh-oh, can't really see it. At the sum,
There we go.
that's one way of doing it. That'll tell you. Otherwise, you can go to 3 and you can go to equals this one, far right. It'll say x equal 0.42. Guess what, Chris? If we go back and we do our other trick, the sum, go look what it is.
0.9421. 0.9421.
It's the same thing. So there, those are two of the ways.
You need to calm down. Just really quick, I saw that and it looks like a metal dog.
So everyone can hear it pronounced wrong. Ready, go.
Poison. Distribution.
Now, this should not be confused with
poison. Or, yeah, that's cool. That's beautiful.
Okay, watching this, I need you to participate with Chris and I. Chris, we're gonna both do this, okay? We're gonna practice. I'm gonna say something and Chris is gonna repeat after me.
Yeah.
Croissant.
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 Now we're gonna drop the T. Croissant.
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 Now we're gonna remove the C and the R, and we're gonna put more of a pois.
Pois.
So ready?
Pois.
Poisson.
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 All right, now your turn. So Chris and I are gonna say it together, and you're gonna repeat after us. Okay? Poisson.
Way to go!
Great job. So I'm gonna
Almost
explain
10
what it
minutes
means
into this one, we've gotten a little distracted.
by an example. So let's say in the last 36 years in the United States, we have averaged 1.6 hurricanes.
Wow. What does a 0.6 hurricane look like?
No, like annually. Annually.
Got it.
One average. This is average.
The mean.
Yeah, Chris, exactly. Mean. Now, the question might say, what is the probability of 2 hurricanes to hit the mainland? Now, you know what to do. It's time to go back to the laptop. And I'm gonna convert my tablet laptop back into a laptop. And we're gonna go and find the file.
Kara's texting Isaiah.
That's my
They're
girlfriend.
dating now.
That's my girlfriend, Kara. We're gonna go to Poisson. We're gonna open it. Whoa! There it is. Oh, this is. There it is. Oh, that scared me.
There you go.
Poisson. Welcome. Okay. In data, it says mean expected number of events of interest. We're gonna put the mean number of hurricanes. Chris, do a little zoomer back. What is it?
Da-na-na-na-na-na. Where are we? 1.6.
1.6.
There it is.
1.6. And then how many was the likelihood that 2 will occur? What does it say, Chris?
That 2? 0.
Oh, that's 1.
Yeah.
Boom. 2.
0.2584.
Exactly. That's it. That's it. Now, another example. What is the probability that 6 or more hurricanes will occur?
Wait, come on. 0.9987.
Wow. So it's very likely that less than 6 will occur.
Yeah.
So that's pretty
I guess
good.
that's a good thing.
That's all of chapter 4 and 5.
That was beautiful.
Thank you for this time.
Thank you.
It's been great.
Yeah, it has been.
If you really love stats, like Chris and I,
Raise your hand.
we want you to raise your hand right now. Chris is
I do. Thank you so much, Jesus.
Live
for
your
this
life.
program.
doing 2 things:
Loving Jesus.
loving Jesus and studying stats.
Yeah.
Okay?
Just really want to thank everybody for coming out here. Isaiah and I have been on the Isaiah and I have been on the grind for it's been half an hour now. It's been real rough. He's got all the lessons planned done. I just came here from accounting, but this has been really helpful, and I hope you guys are encouraged. You're beautiful.
Anyways, this has been Chris and Isaiah.
Yep.
Studying business statistics, section BUS 352. Professor
Yes.
Todd Merwin. God bless.
God bless you guys.
Sometimes, during a long, grueling study session, Chris and I like to unwrap a good old Nature Valley bar.
Just in case you guys didn't know, these are one of the messiest bars you could eat. That in Phoenix is definitely one of the meltiest. If you're planning on walking anywhere and it's above 80 degrees in your pocket or anywhere this is stowed, it will melt and it'll get extremely squishy. Anytime, any weather, this will be the messiest bar you've ever eaten. Please carry a trash can, a bag. It could get hurt. I've recently been learning how good of a father God is. Been really cool.
Explain.
Long story short, the Lord's been showing me how He wants to take the full responsibility of being our Father and giving us everything that we need, and He's the one who supplies that, rather than us depending upon our earthly father. There's nothing wrong with depending on your earthly father, but He is the one who wants to be like everything for you in the example. It's been really cool.
You know, Chris and I want to encourage you right now to spend some time in the Word. You know, we want
It's good.
for real.
No, for real. I need to get into the Word
Me
more.
too. I think.
This season has been lacking for me because usually I do it in the morning, but bro, I've been going to bed too late. And I know when I try to do it at night, I fall asleep. So
But yeah, get in your Bible, talk to the Lord.
with the Holy Spirit will help you with stats.
It's true.
I don't know what I'm doing in this program, and he's been helping me. And he's helping me through Isaiah and Todd.
Professor Merwin